Welcome back, chemistry fans. Today, we are going to finish up our unit talking about redox reactions. Here is the final portion of it. We've been building up to it. We've talked about net ionic equations. We have been talking about how to assign oxidation numbers. Now we're going to try and put all this together into one solid topic. All right, so let me share with my screen with you, and we will get going on this then. Ooh, maybe. Here we go. Okay, so in this process, we talked about last time, there are some unbalanced equations that just simply cannot be balanced. And that's because they end up losing some of their, or they're missing pieces. And it's because of the net ionic equations where we removed them. Now we're going to try and put them back in to balance them. But in the process, we need to also know how to assign oxidation numbers. So let's remind you what these two words actually mean, because we're going to be referencing them in this oxidation reduction reaction. Oxidation means that you are losing electrons. Reduction means that you are gaining electrons. These must happen simultaneously in conjunction with one another. If you are losing electrons, you cannot simply have them float off into the air. There has to be a corresponding element that wants to take the electrons. So redox is why this happens. Now, there is some details in this that we also need to be aware of. There is such a thing called the agents. They are the starting materials that do the opposite task. If you go through oxidation, that's because you caused reduction to occur. So you are now called the reducing agent. If you go through reduction, meaning you've gained the electrons, that means you caused oxidation to occur. So even though you've gone through reduction, you are the oxidizing agent. So keep those very convoluted opposite logic things in mind as we move forward so that we can refer to them correctly. Now, what you saw, there are two elements. One of them oxidizes, one of them reduces. So we are going to have to be able to identify those elements. And doing that process is called half reactions. In a half reaction, we are going to change the oxidation state, the number, the charge of one individual element. One of them is going to get lower. It's going to become more positive. Sorry, it's going to become more negative. The other one is going to increase its charge, and that's going to become more positive. Well, we have to think about what that means. If you are an element that gets more negative, that's because you've gained electrons. Gaining electrons is reduction. If you are an element that gets more positive, that's because you've lost electrons. Now, what you should notice from our seventh type of reaction, where it dealt with electrons, notice where the electrons are located. This should give us a strong indication as to what type of reaction these are. This is an electron on the right side, meaning it has provided an electron, it's given it away. It's losing an electron. That means it is oxidizing. If there is an electron on the left side, that means the electron has been given to it. It is taking the electron. That is in a reduction process. Now, let's keep in mind what terms we just discussed. If this is oxidation for iron, that means this is the reducing agent. If this cerium, if it is gaining an electron, it has gone through reduction. That means that this is the oxidizing agent. Okay. Now that we understand that process, and here it is reiterated, the agents. Reducing agent is the one that causes oxidation. Oxidizing agent is the one that causes reduction. So here it is written out again. Notice what happened to the zinc. If it has no charge, it is 0. It got more positive, meaning that it has lost an electron. The copper, on the other hand, has become more negative. You're saying, well, it became 0. That means, though, it went from a positive to closer to the negative side. That means it gained an electron. Because of that term, the zinc actually has gone through oxidation. That's why it's called the reducing agent. The copper has gone through reduction. That's why it's called the oxidizing agent. All right. Moving on. Same exact steady pace here of what you're seeing, just in a different visual process. The A has lost an electron. That means it's oxidizing, meaning that this is my reducing agent. The B has gained an electron. It's gone through reduction. That means that it is the oxidizing agent. Okay. Now, what do we do with this? We want to try and balance the number of electrons that have been lost and gained so that we can balance the reaction. Well, in this case, it's very simple. I lost one electron with the iron, oxidation. I gained one electron with the cerium, that's reduction. So it does balance out. And you could actually prove this if you add the charges on the left and the charges on the right, they both equal up to be +6. Now we move forward. And what I want you to see here is a similar thing, but the oxygens, remember, they don't change their charge. It was the manganese, which is a part of the compound, which changed its charge. So the manganese, it must have gone from a +7 on the left to a +6. That means it lost one electron. That means it went through oxidation, meaning that this is my reducing agent. The sulfur, it changed from a +4 to a +6. That means it lost electrons. It lost 2 electrons. So that means that it went through oxidation. That means that, the manganese gained an electron. That means it was reducing. That means it's the oxidizing agent. And the sulfur, on the other hand, it went through a loss of 2 electrons. And what that means is it went through oxidation. That means that this is my reducing agent. Okay. More examples. In this one, we got to pick out what element changed its charge. Well, the sulfur did. We could see that hopefully here. The sulfur went from a -2 to a +4. Well, what does that mean? It means it lost 6 electrons. In losing 6 electrons, that means that it went through oxidation, meaning this entire material, all of it together, is my reducing agent. Now, the oxygen, it went from a 0 to a -2, and you can see it did that in 2 different locations, but it's consistent. So it gained electrons, meaning that it went through reduction, meaning that this material is my oxidizing agent. Now, more example. Let's see here. Manganese, it changed its charge. It was a +4. Now it's a +2. That means it has gained 2 electrons. Because you gain, that means you are reduction. That means that the entire material is the oxidizing agent, not just the element. The entire material is the oxidizing agent. Now let's take a look. The chlorine went from a -1 over here to a 0. Now, I understand right here it went from a -1 to a -1, so we won't focus on that one. We will focus on the one that did change its charge. That means it lost electrons, so it went through oxidation. That means that this is my reducing agent. I believe it looks like I got one more example here. So the zinc goes from a 0 charge, because it's an element by itself, to a +2 over here. That means it lost 2 electrons. That means it went through oxidation. That means that this material is my reducing agent. The copper went from a +2 to a 0. That means it gained 2 electrons. That means it goes through reduction because it's gaining electrons, meaning that this is my oxidizing agent. Okay, let's practice it without the arrows provided to us. We have to assign the charges here. Elements by themselves are 0. We know that there's a rule that oxygen is always -2. Therefore, we see right here, the oxygen went from a 0 to a -2. That means it gained electrons. That means it went through reduction, meaning this is my oxidizing agent. Now, let's take a look at iron. Iron, if the total charge over here is -6, the charge on each one of these ions must be +3 because there's 2 of them. That would give us a sum of +6 to cancel it out. So it went from a 0 to a +3. That means it lost electrons. That means that it went through oxidation, meaning this is my reducing agent. Let's try chlorine. Chlorine over here is a 0. Over here, it's a -1. Sodium is a +1. Sodium is a +1. It didn't change. Bromine is a -1. Over here, it's a 0. That means that the chlorine went from a 0 to a -1. That means it has gained electrons. That means it went through reduction. The bromine, on the other hand, went from -1 to 0. That means it got more positive. That means it lost electrons, went through oxidation. That means that the entire NABR is my reducing agent, and the chlorine would be the oxidizing agent. Okay. Looks like I got a couple more examples. Let's do these. Manganese starts at 0, so does oxygen. Over on the right side, it's +2 and -2. So the manganese went from 0 to +2. That's losing electrons. That means it went through oxidation. That means that this is my reducing agent. Oxygen, on the other hand, went from 0 to -2. That means it gained electrons. That means that it went through reduction. That means that this is my oxidizing agent. Now, the next one's really tough because there's 4 elements in this. So we have to assign the charges of each one. I know that sulfate has an overall charge of -2. I know that hydroxide has an overall charge of -1. So if sulfate, SO4, has a charge of -2, this copper must be +2 on this right side. Nothing is changing on this one. I'm going to save us a step. All of the charges stayed the same. If this is -2 total, this is +2. There is no oxidation reduction in this reaction. Crazy. All right, here we go. Now, last topic. I introduced this concept that this is unbalanceable. We have the goal now to balance this. And you say to yourself, why is it unbalanced? Because there is no oxygen on this side. So because of the net ionic reaction, oxygen is removed, we are going to place it back in. So there are steps that we must follow. And here it is. There are many steps to this process. The first step is that we must split it into half reactions. That's what we've just been doing. We've been assigning oxidation and reduction labels. Then we are going to balance the H's and the O's. We're going to balance the O's with adding H2O. We're going to balance the H's by adding H positive. Then we are going to balance the half reactions. And then we are going to start balancing their charges. And then we're going to cancel out whatever is the same on both sides. So we're left with our final answer. It's going to take a little bit of time, but we're going to figure this out together. Let me show you the process. into half reactions. You will get practice at seeing where these elements are that change their charges. You know it's not going to be based on the oxygen, and I will tell you right now that this sodium does not change its charge either, because we have rules that say it's always going to stay as a +1. Therefore, the only two elements that are left are the AS and the I. So this is where we are going to split our half reactions. We're going to take these two materials and split them up. So I'm going to write this in two different ways. NaAsO2 producing NaAsO3. Then my second half reaction will be I2 produces HI. Okay. Second step says balance everything that's not hydrogen or oxygen. So that means I need to put a 2 in front here to balance the iodines. That's step 2. I have one Na on both sides at the top up here. I have one As on both sides, so that's okay. Now we move on to step 3. Step 3 is to balance the oxygens. You balance oxygens by adding water. So I will add 1 water to the left over here. That will give me 1, 2, 3 oxygens, which is the same as over here, 3 oxygens. Fourth step, balance hydrogens. Well, I just added 2 hydrogens, so now I need to balance that by adding 2 hydrogen ions to the left. On the second half reaction, I already have 2 hydrogens, so I need to add 2 hydrogen ions over here. Now, all of my elements are balanced. Step 5 says that we need to balance the charges. We'll notice here that there are 2 positives. So that means I need to add 2 electrons, which have negative charges. Down below, I will add the similar 2 electrons down here. Now, all of my elements are balanced, all of my charges are balanced. Now I can simplify by adding these 2 reactions together. So I'm going to write everything on the left and keep it on the left. H2O plus NaAsO2 plus 2 electrons plus 2 hydrogens plus 1 iodine produces NaAsO3 plus 2 hydrogens plus 2 electrons plus 2 HIs. Now the final step is that you cancel out similar terms. I've got 2 H's on both sides, they go away. I've got 2 electrons on both sides, they go away. Now I am finished. I have my completed answer. Everything that's left over is my final answer. All right. We got one more example that we're going to do. Maybe, oh, we got a couple more examples. Sorry. Okay, so we're finally back to that question of what do we do with that oxygen? So we are going to split this into 2 half reactions. One of them, again, is going to be iodine. So I will write HI producing I2. And then my second half reaction will be based on the chlorines, HClO3 producing HCl. Now you're saying the chlorine will always have the same charge? Not in this case. Because it's a part of a polyatomic ion, its charge would be different. Over here, it will be -1. Over here, it's going to be a +5. So it did change its charge. All right, step 2, balance elements that are not oxygen or hydrogen. I got to put a 2 here. That's the same process we did before. Down below, the Cl's are already balanced, so we don't have to touch them. Step 3, now balance my oxygens by adding waters. So I got to add 3 waters over here to get the 3 oxygens that are here. Step 4 is to balance hydrogens. So I need to add 2 hydrogens, just like we did before, but they're hydrogen ions. Over on this side, I've got 6, so I have to balance 6 hydrogen ions. Step 5 is that we're now going to balance the charges. Well, that means I need to add 2 electrons here. Down here, I need to actually add 6 electrons. Well, now notice what happened. My charges are not the same. So what this means is I have to balance my charges by multiplying everything by 3. If I multiply everything in here by 3, I would have 6 HIs, 3 I2s, 6 H's, and 6 electrons. Now my electrons will be able to cancel. So let's add everything together and we have our final answer. So I have 6 HI plus 6 electrons plus 6 hydrogens plus HClO3 producing 3 iodines plus 6 hydrogens plus 6 electrons plus HCl plus 3H2O. Everything is balanced. Let's cancel out like terms. 6 electrons, 6 electrons, 6 hydrogens, 6 hydrogens. I'm left with my final answer. Now, here gets back to the original question. We didn't know how to balance this without getting rid of the net ionic equations that we did. So we got rid of water. Now we put it back in and it's balanced. Seems like a long process to do that, doesn't it? You'll get okay. We'll be okay with it. All right. We'll do 1, 2 more here, and then we'll call it a day. So I've got 2 half reactions. One of them happens to be, let me scroll it down so I can actually see, or let me move my head out of the way. There we go. So the 2 half reactions, I can see that bromine is going to have a -1 over here on the right. It's going to have a +5 charge. So I've got my 2 half reactions. All right, the second half reaction, manganate, permanganate, and it's going to produce manganese dioxide. Now, these are not balanced, so we're going to have to do that. We start second step, get rid of elements or balance elements that are not oxygen or hydrogen. They are both balanced. So now we go to the oxygens. I need to add 3 oxygens over here by adding waters. Down below, I have 2 extra electrons on the left, so I need to add 2 waters over here. Now I've got to balance my hydrogens. I'm going to have to add 6 hydrogens to the left because there are 3 times 2, 6. I have to add 4 hydrogens over here because it's 2 times 2 for the hydrogens. Now, my electrons. Now, notice there's 1 and 1. They canceled each other out, so that's okay. So I do need to add 6 electrons to the left here. But notice this. 4 total -1. That means I've only got a +3. That means I only have to add 3 electrons over here. Now I've got 6 electrons and 3 electrons. I need to multiply all of this by 2 so it balances out. So I would have 6 electrons, 8 hydrogens, 2 of the permanganates, 2 of the manganese dioxides, and 4 of the waters. Now everything is balanced and we can simplify. So I can write everything down. 3H2O plus Br -1 plus 6 electrons plus 8 hydrogens plus 2 permanganates produces bromate plus 6 hydrogens plus 6 electrons plus 2 manganese dioxides plus 4 waters. Now we cancel out like terms. 6 electrons goes away, 6 electrons goes away. 6 hydrogens, but oh, wait. I've got 8 over here. So now it becomes 2 because I'll have 2 left over after I cancel out 6 of them. I have 3 waters. They cancel out with 3 of the waters over here. That means I'll be left with 1 water over here. So you don't cancel all of it out if they're different numbers. You just cancel out however many you can. All right, we got our last practice problem. Saved the best. Oh, we got 2 more. Goodness gracious. We got a lot of practice to go here. So let's do these practice and let's get out of here. Split these into half reactions. PbO2 producing Pb plus 2. My other half reaction, I2 produces IO3 minus 1. Okay, my leads balanced. My iodine's not balanced, so I got to put a 2 right there. My oxygen's not balanced, so I will put 2 waters. Down below, I will put 6 waters, and you're saying why 6? Because it's 2 times 3. Now I will balance my hydrogens. I will have to add 4 hydrogens to the left because 2 times 2. I will have to add 12 hydrogens over here because it's 6 times 2 on the left. Now my charges. I have +4 and I have +2. So that means I only need to add 2 electrons over here to get them balanced. Down below, I have -2, and I have +12. Ooh, so that means I've got +10 left over. That means I need to add 10 electrons. That's crazy, 10 electrons. All right, well, these 2 electrons are not equal, so I need to multiply all this top by 5. When I do that, I'll have 10 electrons, I'll have 20 hydrogens, I'll have 5 of those lead oxides, 5 leads, and 10 waters. Now everything is balanced. We can write our final answer. I'll have 10 electrons, 20 hydrogens, 5 lead oxides, plus 6 waters, plus iodine, producing 5 leads, 10 waters, 2 iodates, 12 hydrogens, and 10 electrons. Now we cancel out like terms. The 10 electrons are gone. Electrons are gone. Now, I can't get rid of all the hydrogens, but I can get rid of 12 of them. That will leave me with 8 over here. I can get rid of 6 waters. That will leave me with 4 over here. And now I have my final answer. All right, let's do one more example. Let's see what we can do here. And it's on the bottom, so I can't shift it up. Good enough. Here we go. So I'm going to split this. Ooh. This is going to be split twice. This is too hard. You will never have a question like this. If you do, it's going to have to be written twice. So I would have AS as H2ASO4, and I would have AS as ASH3. We're never going to do this. So I'm going to skip this and we're going to leave it. This will be as tough as we ever need to address. Thank you very much. Have yourself a fabulous afternoon, and hopefully you can practice and get yourself ready. Make sure you have all these steps written out. Bye-bye. Take care.